Okay, we got it. Oh, and of course. Alright, this is a lot easier using this machine. Hello friends, welcome back to the bench. Our patient is something that I've been waiting for quite a while. The BGA Rework Station, which is a lot more professional than the tools I've been using so far. Meaning hot air and that preheater that we modified. It actually works not too bad, and I got some good results replacing the CPU sockets on those tools. Now I have a new tool, so now I have to destroy few more boards to learn how to use this tool. So in an effort of saving you some time, if you receive one of these or if you order one of these, it arrived, and how do I do it? It is pretty intuitive. The user manual is not bad. I found it slightly confusing here and there, but since there's a lot of pictures and a lot of example curves, it's relatively easy to figure out. I don't know why I had so many issues with it figuring it out. It took me about half an hour, maybe an hour, to actually start getting some good results on it. So this is the board that we're gonna replace the CPU socket on. Or actually, in this case, we just want to take it off without any damage to the board or to the socket. So you want perfect temperature. I know I can do it on my previous machine. Now I need to be able to do it on this machine. As far as the build quality and how it comes, it's pretty good. It's pretty good. It's compared to the Yihua, whatever the number that we did, that I've been using so far. The build quality of this one is a lot better, and the main reason is, I'll show you in a second, but basically we have just two controllers, two industrial controllers, with the ability to connect via USB and upload the curves from the computer, which is easier than clicking these, but it's not too bad, especially once you figure out how to actually do it. So let's take a look at it from this angle. Okay, perhaps not the best angle, but that's the best I can do. The cable won't go any further. So we have bed temperature controller. This is a very simple controller, not the very same one, but very similar to the one that we used for the previous preheater. Pretty much the same thing. You just set the temperature and that's it, and it just turns on and off. Nothing special here. This is jdyb.com, and I guess maybe a model is XMTG, hard to say. The second controller, this is typical industrial controller that if you work in a factory or, I don't know, a mine or something like that, you're probably familiar with these. These are like typical that the factories just purchase and install to their relatively customized machines. And if you replace them, you need to reprogram them so it does whatever you want it to do. So this one is a PC410 from Sean, something like that. It's PV, that's our current temperature read through the thermocouple that we connect here. But to be honest, this doesn't really do anything. It only shows you the temperature. You can just disconnect it and ignore this reading, and it works the same. So it doesn't really take the feedback into account. It just controls the temperature on the IR heater, the temperature that the IR gives. And you can use it to produce the curves. And this is something that should produce better results, right? So if we program it that it should ramp up to this point, to this temperature, then hold for say 30 seconds, then ramp up slowly to the target temperature, hold it for say 60 seconds and turn off, right? And we can program that. We have 10 buckets or 10 programs that we can pre-program here, and we select it with this button, and this shows us the current program. So let's turn it on. And actually, before we turn it on, what I really like about this is that the table is, as you can see, separate. I don't have enough room on my bench to actually utilize it properly, so it's kind of a, yeah, it's not even and stuff, but it doesn't matter that much because we're not using hot air, we're using infrared to heat it up. Now, as you can see, this just drops, and it's very hard to actually operate it. Maybe it'll become easier once I start using it, or maybe I should install like some kind of spring over here or something like that, so it stays. I'll think about it. For now, it works not bad. And as you can see, I already removed a socket from one board, but I won't be able to show you that. But we have slight bulging in minimum bulging in the center, and the problem with that is because in the center the temperature is going to be the highest. That's why we have this little ruler over here that shows us the center. That's where the highest temperature will be. With these sockets, since they have the window inside, right, this is kind of a pain because the highest temperature will be in the center. Nevertheless, you can see that the socket has not been damaged, right? It suffered no melting, and not even I don't really see deformation of the socket itself. But this is old socket that we removed, so even if we deform it or even if we melt it slightly, it's fine. But we cannot melt the replacement. So I feel that this will be the highest, the greatest challenge to actually bring the temperature evenly, because center is very hot. Over here it's very hot, and at the edges it's not. The distance between the heater and the board makes all the difference. Just few millimeters of difference, and it's a difference whether the components start flowing or they're not or they're not desoldered. The distance between the bottom heater and the board is rather great. So this is actually something that I do not appreciate about it, and maybe I'm just not using it right. But as soon as you turn it on, this controller starts controlling the bottom heater. So you see it turning on and off to bring the temperature up, but it won't until this controller allows this one to grab power. So this one essentially disables this one. So only once you start, this one starts heating. But what I want to do, and what I normally do, is first I turn on the bottom heater, I bring the temperature of the board, not the heater, the temperature of the board to about 130, 140 degrees Celsius. Then once the board has reached that temperature, then I turn on the top heater. This one doesn't exactly allow me to do that, but we can work around that. But this is something that I would definitely change about this one, and I might modify it so this bottom heater controller is not coupled with this one, so it always, as soon as you turn on the machine, it starts heating the bed. And that probably will be my modification, but we'll get there when we get there. So now, without further ado, let's turn it on. Now, as you work on it, it suffers from the same issue that the bottom heater will just heat up the entire device. Everything will start getting warm. But as opposed to the previous one, this one actually has a big fan over here that you can hear already. And it blows outwards, removing that temperature from inside the box. And it sucks the air from both sides over here. So although this plate is gonna get hot and this is gonna be slightly warm, the inside seems to be fine. The temperature is fine. As far as the thermocouple, well, it's a high temperature wire, so it's springy. It's kind of difficult to place it on the place it where you actually want to place it. But again, this only shows you this temperature over here, which shows 16 degrees right now, which is weird. Now as I touch it, went to 23, so it shows a little lower temperature, but well, it should be 25, yeah, about 25 degrees in this room, not 18. So this shows a slightly lower temperature. This should probably be calibrated. I have few more of, not exactly of these, but I have few more K-type couples, so I can test few of them. Now, how do we use it? This is our example rework temperature curve, and we start with the temperature of 85 and we hold it for 70 seconds. Then we increase the temperature to 150 and we hold it for 35 seconds. Then we increase to 190 degrees and hold it for 50 seconds. And I'm not sure what the last parameter is, 230. Is it the maximum temperature? I don't know. The maximum temperature that the IR will produce is 260 degrees, which doesn't seem like a lot for sure, but it's actually a lot because it's IR. It actually can, so if you're used to hot air and you set hot air to 260, that's not a lot, right? I've been actually doing that on 260, was it? Let's see, hot air, no, even 280 for the big sockets. But for these sockets that we're gonna do now, I've been using roughly around 260. But that's hot air. That's always gonna be the temperature shown on the device is always going to be slightly inflated. It's not going to be the actual temperature pushed to the board. IR is a lot more efficient regarding that. And again, the distance between the heater and the board is very important, because that's going to be the deciding factor as well. So I prepared some program over here. So number 4, let's switch to number 3. So number 1 is this one for lead-free solder reflow. Number 2 is for leaded reflow. It works great. Number 3, what I said in number 3, ramping 1, then we start from 85 for 75 seconds, then we go to 140 for 60 seconds, and third step is 175 for 90 seconds, and we finish. So this is what I envisioned that will desolder the socket. But the problem with that was that it melted. It melted really badly. It melted to the point of smoking. And the speed at which this IR can push the temperature is so great that I even had a plastic component on the board catch on fire. I've never seen that with hot air. Hot air is very slow. This is really fast. So it's completely different procedure than what I've been using with hot air. That's why I'm gonna have to destroy quite a few boards before I actually get a hang of it. But that is always expected with a new tool. All right, now in addition, we're gonna observe with a thermal camera, which I haven't done yet. So this is gonna be the first time for me as well, seeing the actual temperature. Okay, as far as the holders, as you can see, I have them upside down. Unfortunately, you see the shape of it, right? The board should clip on here. I just turned on this phone. It hasn't been turned on for a while, so now it's gonna be beeping all kinds of notifications and stuff. Yeah, just ignore that. So anyways, I cannot put the board on this side because of this shape, right? It just blocks the board. So it needs to be upside down, which means the distance between the heater and the board is slightly greater. I have it set to 300 degrees at the moment, and we'll see. Yeah, and we'll see. As I said, so far I only did one board on it, and I'm not too happy with results, but it's not because of the device. Nothing wrong with the device that I've identified so far yet. Okay, and now let's place it in the middle. This is one of the best features of this machine so far, is this holder. I do need to modify it because the construction, this one is too low, this element, so it just keeps catching on this. The left one is fine, but the right one is just too low. I have to figure this out. I'm not sure how yet, but I'll figure it out. But that allows you to just see, you can just move the board wherever you need. Let's drop down and find the center. That looks like a center. Then we can clamp down like so, and now the board is relatively stable. As you can see, it's swaying because it's not not super stable, but it's good enough. It's definitely better than, well, maybe not better than what I built, but because my build was keeping the board really stable. But this is stable enough, and it accepts big boards. And my stand, my holder was designed just for the boards, nothing more, just for the computer boards. We've measured, these four screws, right? Now I can actually hold all kinds of boards here. So now what we are going to do is turn on the light so we can see something there. Alright, I'm gonna keep the nozzle high because first I want to preheat it. Now let's review our program. So ramping is set to 1. I think that's 1 degree per second that it's ramping. Don't quote me on that. To 85 degrees for 75 seconds. Then ramping up 1 degree a second to 140 for 1 minute. And then to 175. At 175, again, if we drop the nozzle really low, that's going to be too high because it's going to start melting the socket. So it all depends on how low can we go with the nozzle, with the heater, right? So let's do it this way. Let's start recording our thermal image, and it's recording. Let's see. Yep. Here and okay. And so all we gotta do now is just hit start. Let's turn on the fan on the IR heater, the top of the IR heater, and start. Now this LED is lighting up when it's ramping up, and we see it's ramping up slowly from 20 degrees, whatever. Oh, and yeah, I always forget about this one because, as I said, it's not really needed. Oh, perfect. Okay, so now we see the actual temperature on the thermocouple on the PV. On SV, we see what's the temperature on the IR heater. And our bottom is on, so now the temperature on the bottom heater is increasing because now it gets the power. So that's probably that one modification that I will make to this, is to just decouple these two. I want to be able to preheat anything I want without turning on the top heater. Now this shows us which step we are on. We're on step 1, which is it went up to 85. Our actual temperature is at 44, 45, 46, 47, climbing slightly, slowly. And this LED, the middle LED, has it's lighting up, so it's on the settle point. So now it's holding the temperature. It's holding 85. And then the top LED will shine when it's ramping up, and the bottom one when it's ramping down. We have 126 already on the bottom heater, but that's not the temperature of the board. So once we get to 300 on the bottom heater, I expect the board should be at around maybe 80, maybe 90, considering how far the board is from the actual heater. Now we switch to step number 2. So that's going to be, if I remember correctly, I don't remember, but it was somewhere around 130, 140, something like that. There's already 199 degrees on the socket as far as the infrared camera is telling me. So that's surprisingly high. We're at 202, 204. It definitely, the speed at which this device heats up the components is amazing. I desoldered like all kinds of stuff off one board, capacitors, coils, transistors, even the plastic M.2 socket without any damage, which was really cool. And it's amazing when you look at it, it just magically starts floating. You just turn it on, you wait a few seconds, and components start floating. And you don't hear anything because it's not like a hot air that is really loud and everything's blowing away. No, it just magically, the board starts heating. It's amazing. It's the first time I work with the IR station, so it is definitely amazing to me. Okay, we switched to step 3, and we're going to 175 if I remember correctly. The socket is at 146 at the moment. No signs of melting or anything. Now remember, our heater is really high up, so this probably will not melt our socket enough. We are seeing roughly 220 degrees up there on the thermal camera. So it is at the temperature that should melt the solder, but it looks like either the thermocouple shows temperature too low, but it aligns with the temperature set on the IR heater. It matches very nicely. So I expect that it's my thermal camera that is a little bit off and showing a bit too high temperature. No, there's not even a movement from the socket, and it is done. So we're gonna switch off now. There. All right, it's switched off, so we're done. So that is how we do if we need to do a reflow of anything. You can program exactly based on the observation, based on the, if you have the same device for reflowing or resoldering or stuff like that, you can program it exactly and replicate your results every single time. That is the main benefit of this. Okay, the socket is not even slightly want to get off. So what I'm gonna do is switch to program number 4. And program number 4 has only one step, and I'm at 260. I don't want to be at 260. Let's do 175 for 2 minutes, and that's the end. So when I switch it on, it goes to the set temperature, and it just holds it for 2 minutes. And now let's see the thermal image. It dropped to 186. I can smell a little bit of burnt plastic, but that's mainly probably because the heater is dirty because of the fire that I had on the board. The thermocouple says our temperature is about 150, while our thermal imager says we're about 206. So we have relatively high discrepancy. So now this explains why, when I was doing it initially, I was bringing the socket to the temperature of 240, 250, with an expectation that the solder definitely is flowing. But it wasn't, because my imager appears to show the temperatures highly elevated. This might be because how the sensor works. It only shows like surface temperature, of course. So this might be the reason for it, but it looks like we're like 225, while we're actually at 174. So definitely this is not going to be flowing, right? Nope. But what I'm doing now is I'm just kind of preheating it. I want the board to be nice and hot, and that was 2 minutes. There. Now we're gonna drop a little, not too much, and start it again. Another 2 minutes of 175. The actual temperature is even higher now, 178 on the thermocouple, 177. The temperature shown on the thermal camera is 220, which is good. Still no movement from the socket. Since there's no hot air, it's very easy to operate. I can put my fingers pretty close to this, see, without any burning. Right? The rest of the board, like I can touch the board here, it's lukewarm. So it gives us the ability, because hot air will just have to escape somewhere. So it's going to be heating up everything around, which means you gotta cover everything, all the plastic parts, with either aluminum foil or something, maybe Captain tape. But with IR, there's no need for that. I have perfect access to the socket, and I'm not being burned. Plus, it's a lot quieter. This would have been a very loud experience when there's a hot air blowing from the top, hot air from the bottom, maybe fume extractor. It gets pretty loud. This is a lot more convenient. Okay, we still have no movement from the socket, so let's drop a little lower. Just a little, and another 2 minutes of heating. Thermal camera still shows us roughly 225. Now, this socket that I removed yesterday, I was using 260. But I don't want to use 260. I want to use lower temperature, and I want to find the lowest temperature, because I was heating it from high up. So I don't need, if I manage to get the nozzle or the heater close enough, I should be able to use lower temperature, like 175. 226 on the thermal camera still. Still not even nothing from the socket. So let's let it finish, and we're gonna up the temperature to something a little more appropriate. The melting point of lead-free solder should be roughly around 230, maybe 220, and that's what the thermal camera tells us, but it is wrong. There's 175 on the thermocouple, so there's definitely not 220 there. Okay, we're done. Now let's set it to 175. Let's set it to 195 for 2 minutes and start. Now we should see on the thermal camera that the temperature will skyrocket. It's probably gonna reach over 300 on the thermal camera. And the thermocouple is up to 170. Okay, that brought us to 250 on thermal camera, and no movement from the socket still, which is to be expected. So now, instead of upping the temperature, let's lower the nozzle a little more, and let's start it again. Okay, no movement from the socket. Let's drop all the way down, almost all the way down. So now this will, if the temperature 190 is too high, then the socket is going to start melting. What was it? 195, yeah. There shouldn't be any smoke when you do this, unless there's some dirt, some gunk on the board or on the socket. But there shouldn't be any smoke. If you see any smoke, the temperature is too high in some point. And if you see smoke and the socket is not moving, not melting, or there's no movement from the socket, then it's the problem of temperature spread. It's too high in one point, not high enough in other points, and that is the main issue with this job. So this is now the lowest I can go, because the components around it will not let me go any lower. And let's give it one last try on 195, but I think we're gonna have to increase to about probably 220, 230. When I was doing it on 260, it's not like it just flew off. It's not like it was floating, right? I still had to just kind of lift it and use a little bit of force to work against the solder that is just on the brink of melting, on the brink of flowing. It's soft enough that you can pick it up, but it's not flowing. But that's lead-free solder. Very important to remember. Now we have movement from the socket. The solder became soft, but not soft enough and not in all places. So we're very close. Let's see if there's any melting. I don't see any melting. So let's up the temperature just slightly. 195, 205, 205, and this should give us, this should be capable of lifting if the entire socket heats up at the same time, because one corner is ready to lift. This one, now it's still solid because we turned off for a second, but we're at 196 and the thermal camera is showing 250 roughly. Right, it shows effectively, it looks like it shows 50 degrees higher than the actual temperature. Again, it's a different form of measurement, right? And it's an imager, so it's not exactly meant for measuring temperatures. It's more, designed to show you the temperature differences and the thermal image, not exactly to measure temperatures. I was using it for temperature measurement, but as you can see, that was not the best idea. Okay, looks like 205 is not enough after all. So let's go with 210. Because we're very close, so now I'm going to be going 5 degrees at the time, because I don't want to melt it. And also the most important, because if I melt the socket, it doesn't really matter that much, but I don't want to damage the board. That's the main problem here. I may need to set a higher temperature at the bottom, but primarily that temperature is going to be from the top. That's why on this particular machine, on this technology, the bottom heater doesn't really matter that much. With hot air, it matters, it makes all the difference. But with this one, not that much, because it heats up only one side of the board very nicely and very quickly. Okay, half of the socket is melted. Meaning the solder is melted. Okay, we got it. And of course. Alright, this is a lot easier using this machine. Let's see the temperature. What's the temperature of it? 250, so around 200 degrees. Now let's see, I don't see any ripped pads on the socket. Let's switch it here, and looks good. I'm not too crazy about this corner over here. Looks like we had most issues in that corner, but the most important thing that I see over here is that there is no bulging anywhere, so we did not overheat. What was the temperature? 210 degrees. That's our magic temperature then. Camera shows a lot higher, but that seems to be our magic temperature. 210, and the nozzle needs to be all the way down, at least for 1151 socket, because or 1200, they're kind of similar, or as far as the shape and the size wise. The AM5 sockets will probably have to use higher temperature, I would expect. And that 210 is like right on the edge. It's probably 215 that we should use. That would make it easier, because the right side over here melted first, and this top left side melted last. I'm not sure why. I thought I put it in the middle. Yeah, it's perfectly in the middle. So I'm not sure what's up with that. I will have to look into that. But consider how much easier it is than using hot air. And again, I can still touch this side of the board, right here, here. All of this, well, it's hot at the top because it's right above the heater. Yeah, it's hot to the touch for sure. The board looks perfect. I can't see anything wrong with the board. So that 260 that I used for this socket, it was just too much. That's why the board bulged a little bit. But that was the purpose of this exercise, to find the lowest possible temperature. That's why it took so long. The lowest possible temperature to desolder the socket. So it looks like it is around 210 degrees, and probably we'll need to increase it to 215 to just make it a little more consistent. Now, one last thing that I think it's pretty cool about this is that now, after this procedure, I can just remove the board to let it cool, and technically I could put another board. Everything's hot. All right, we're at 300 degrees at the bottom right now, 255. See, if you do it quickly, yeah, it didn't even have chance. It didn't even have a chance to heat up too much outside over here, or on the sides or front. A very nice design. Now, one last, but the most important thing is that with this machine, now, if I find a perfect temperature curve for, say, this socket or that socket or this chip or something else, then I can either give you the numbers and you can program it here, or I can give you the actual file that you can upload to your machine to perfectly replicate what you see on my video. That is I think that is the main benefit, because I kept saying that, you know, don't take my temperatures literally, don't take them exactly, because every machine is slightly different and I have no idea what the actual temperature here is. As you can see, my thermal camera is not very accurate when it comes to showing the actual temperature. That's why, that actually explains why I had so many issues previously, and how many boards did I have to destroy to learn how to use the hot air for removing and replacing the sockets. This one, as you can see, on second try, just second try, and the socket is perfectly removed with a lot less effort than when using hot air, and there's no damage to the board. So textbook job. Right now, all I have to do is figure out how to actually replace those sockets using this one, and I expect the temperature should be a little bit higher to do that, because the solder really needs to get really soft so it sits properly. So probably 225, maybe 230. But it's hard because that's right at the edge of a plastic actually melting on the socket. We'll get there when we get there, and I'll be able to just give you the file, give you the actual temperature curves that I use for this particular board or that particular board, right? So we can have curves for each board size, each socket type, or some chips, like on Surface Pro 5s, there's always an issue that it doesn't see the SSD, and I tried reflowing it using hot air, but now I can try reflowing it using this, and then if it works, I can just give you the file and you can fix your Surface Pro 5 as long as you have this machine. How much does it cost? $451.34 with shipping from New York, if I remember. No, New Jersey. I live in Atlanta, so I prefer getting it from New Jersey, but you can also get it from California. I think Chino, and that's usually where all that stuff comes from. And it got to me in just two short days. I ordered, I think, on Monday, and it was here on Thursday, or I ordered, yeah, something like that. So far, I'm very happy with it, but we're gonna keep working on it, and we'll see, because I still have the stock of boards that I need to fix. So we'll see how, well, I can already tell that this is going to save me a lot of time. A lot of time. I definitely, so far, I recommend it. It's a completely different experience using the infrared heater. A lot better experience. If you've never used these, as I haven't, I was so surprised how quickly it heats up and how stable the temperature is. It's amazing. I wish I had that a long time ago, not playing with hot air. Not to say that you can't get job done on the other with the other station, but this is extremely valuable improvement. Definitely recommend it. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.